yourself. Just speak out. Tell me, what are discussed in the previous class, last class?
Sir, from the third unit we have discussed field at point P due to straight filamentary conductor, sir.
Okay, fine. What is the final equation of magnetic field intensity H?
Sir, once you repeat, I did not.
What is the final equation? We can find out the magnetic field intensity. H is equal to the last equation. Last
equation, H is equals to I by 4 pi rho L. Rho into cos alpha 2 minus cos alpha 1, sir.
Cos alpha 2 minus cos alpha 1. What is the A pi r? What is the unit vector? A pi r, A rho or A pi?
A phi, sir.
A pi. Okay. I by 4 pi rho cos alpha 2 minus cos alpha 1. This is the finite. Okay. Finite straight current carrying conductor. The infinite?
For infinite, I by 2 pi rho A phi, sir.
A pi. Okay, this is the infinite. The semi-infinite?
Semi-infinite, I by 4 pi rho A phi.
I by 4 pi rho A pi. This is a semi-infinite. Okay, fine. Very good. Please mute. Okay. Today, topic about the magnetic field intensity H at axis of circular loop. Magnetic field intensity capital H at axis of circular loop. It's a very important topic. Circular loop. Okay. First, okay, I am writing the question first of all. Please observe the screen. A circular loop. Circular loop. First, I write the question. Please observe the screen. Located and x square plus y square equal to 9. Z equal to 0 carries a direct current. Nothing but steady current. Direct current of 10 amperes along the direction of A pi. Along the direction of A pi, determine H at 0, 0, 4 and 0, 0, minus 4. Okay, 0, 0, 4, 0, 0, minus 4. Okay. First, we can find out the magnetic field intensity, capital H, axis of circular part, circular loop. Okay. First, I draw in the 3-dimensional view. This is the XYZ coordinate system. This is, I draw the 3-dimensional. This is X. This is Y. This is Z. X, Y, Z. Okay. In this X, Y, Z, we have to assume the circular loop. The circular. I draw the circular. Okay. Circular path. Okay. We can find out the magnetic field intensity H, axis of circular loop. Okay. Find H. Okay. First of all, I'm assuming the cylindrical coordinate system. What are the parameters cylindrical coordinate system? Rho, phi, z. Assume the parameter. First, rho is nothing but the distance at a point P. Okay, that we are assume this is the origin to some point. Okay, this point we can assume the differential length dl. Okay, differential length dl. This is nothing but current is I, current flowing in the anti-clockwise direction. This is the I. We are using the right hand thumb rule. Okay, right hand thumb rule. Nothing but this curl finger, it is denoted by current. Curl finger it is denoted by current. Thumb nothing but magnetic field intensity, capital H. And we can find out the magnetic field intensity in the upper direction. What is the upper direction? In the Z. Up nothing but Z. Okay, this curl in the anti-clockwise direction. Okay, current in the entering and leaving. Okay, in the circular motion. Okay, we assume the right hand thumb rule. Okay, we are assuming the right hand thumb rule. In the thumb, we can find out the in this way, we can find out the magnetic field intensity. This point, we are assuming the this point is point P. This point P, it is located 0, 0, we can write the H. Only in the Z direction only, we can consider Z direction. Only we can consider Z direction. We can find the magnetic field intensity by using right hand thumb rule. Okay, curl finger nothing but current. This thumb is nothing but magnetic field intensity. Magnetic field intensity. It is nothing but we can consider that this is the rho. We know that rho is the distance. Phi is nothing but we know that this is azimuthal angle with respect to the x-axis. This is a pi. We can assume this point P to this one. I think this is a rho pi z parameter. Okay, just don't confuse. I'm writing the h. Okay, just this is the x y z coordinate system. This is the h. Okay, height of this. This is the h. Okay, same as the Cartesian coordinate system. Okay, don't confuse. That's why I'm writing the h. This is the h. Okay, this is the h. Rho pi z. Just assume the right hand thumb rule. Okay, P 0, 0, H. Okay, in this direction to find out the magnetic field intensity. Okay, DH, differential magnetic field intensity. Okay, at a point 0, 0, H, I'm writing at a point 0, 0, H. We assume the 0, 0, H. Okay, we find out the what is the Biot-Savart's law, differential magnetic field intensity. DH bar is equal to, we know that according to Biot-Savart's law, ideal in the R vector 4 pi R cube. 4 pi R cube. We know that the using Biot-Savart's law, DH bar is equal to ideal into R vector by 4 pi R cube. Okay. First of all, I am writing the in this situation cylindrical coordinate system is observe the screen. Okay, this equation one we can take this equation one. Okay, cylindrical coordinate system. Assuming cylindrical coordinate system. Cylindrical coordinate system. What are the cylindrical coordinate system differential length? We know that directly writing d rho a rho plus rho d pi a pi plus dz az. Okay, since in this situation z equal to 0, okay, z equal to 0, nothing but z equal to constant plane. Okay, z equal to constant plane, z equal to 0 for a given loop. So I'm writing z equal to 0 for given loop. So d rho equal to dz equal to 0. I am consider differential length is equal to rho d pi a pi. Okay, what I have discussed differential rho. In this situation, only this is the pi. Pi is the nothing but the circular motion. What is the limits of pi? What is the pi? Limits of pi? Nothing but 0 to 2 pi. 0 to 2 pi. We know that. Okay, this is the pi. This is the angular motion. We can pi. This is the differential. This is the d pi. We can connect it this point. Please observe the screen. We can connect the some differential length to dl. This point we can connect the differential length to at a point P. Okay, at a point P. This direction nothing but in this direction. Okay, this and this opposite direction. Okay, please listen. This is the unit vector is the r vector. Okay, this is the vector r, unit vector ar. Okay, this is the equivalent opposite direction. I write in dotted line. This is the arrow. This point is also differential length dl. Okay, this is the minus arrow. The opposite direction, this is a minus arrow. This point we can connect to the magnetic field intensity also. Okay, listen, observe the screen. Differential length is equal to rho d pi a pi. Okay, I am given the box. Only I consider the a pi only because of this circular loop. Okay, from figure, listen, I am writing just figure. This is z, this is the origin, this some point, distance. You can connect it this one, this direction, and in this direction, this is the in this direction. Okay, from figure is the origin. Okay, this point, just keep it in your mind. This what is this? This is r vector. This is the h. Okay, what is the unit vector? This is the unit vector of z from figure. Just keep it in your mind. This figure I'm writing. This figure I'm rewriting in the below. Wait for some people is joining. Okay, h a z is a row, unit vector of arrow, is r vector. From figure, row arrow, nothing but in this direction. This is row arrow plus we can same direction plus r vector that is equal in the opposite direction. I think minus HAZ, but I am writing the HAZ. Just don't confuse. I just replacing H is Z. Okay, don't confuse. Okay, rho arrow plus r vector HAZ. Then r vector is equal to HAZ minus rho arrow. Okay, this is second one, very important. This equation. This is r vector. Okay, this is the r vector. So we can write the above according to Biot-Savart's law. This is dl vector r vector. Dl cross product of r vector. Okay, I am rewriting just in the cross multiplication. And they using Biot-Savart's law. Dl vector and r vector that is equal to, we can form of the matrix. Okay, what is the, I assume the parameter cylindrical arrow a pi. This is the AZ. Arrow a pi AZ. First of all, I am writing the differential length dl is equal to, in this situation only a pi consider. In this situation only a pi consider. Nothing but this is a rho, this is a d pi. This is nothing but 0, 0. The matrix form. This r vector is equal to, writing r vector, this is the minus arrow, this is HAZ, H. This term will be 0. This term is 0. This is the minus rho. This is the H. Just cross multiplication. You can dl vector and the r vector is equal to the cross multiplication. I write it directly. Rho H d pi arrow plus rho square d pi AZ. What I am writing? We can find the arrow direction. Rho H d pi minus 0. Okay, this multiplication, cross multiplication. In the matrix, we can find the a pi. That is nothing but 0. There is no need of a pi. This is the AZ. AZ is nothing but rho square d pi AZ. Rho square d pi AZ. Okay, rho square d pi AZ. Just keep it in mind. What is the r vector is equal to? Know that in the above equation, r vector is equal to magnitude of r equal to is above rho square plus h square. Just keep it in mind. In the above, in equation 1, we can substitute the equation 1. Okay, dh bar. We can substitute the equation 1. very important. We can substitute equation 1. Okay, what is this equation 1? According to using Biot-Savart's law, magnetic field intensity dH bar is equal to what is this? A direct writing I by divided by 4 pi. What is R vector? Nothing but square root of rho square plus s square power of rho square plus s square. Square root of rho square plus s square. Directly writing, and I am writing this is the rho square plus h square power of 3 by 2. Okay, power of 3 by 2. What is this above? dl into r vector. dl into r vector, nothing but this one. dl into r vector. Okay, I am writing this side. Rho h d pi a rho plus rho square d pi a z. Okay, in this situation, I am writing this is a rectangular coordinate system. Note a point. Simple way, arrow will be cancelled. Why this arrow will be cancelled? That is nothing but equal and opposite direction. In this diagram, arrow is a circular path. Circular path, nothing but this is the arrow. This is the arrow. Unit vector of arrow. Unit vector of arrow. This is a minus arrow. Unit vector of equal and opposite direction. Okay. Due to symmetry condition, it will be cancelled. Arrow will be cancelled. That I am writing only. Arrow will be cancelled. Okay, I writing dH bar is equal to, I think is understanding. That's why I need nothing but note a point. Just writing. Just keep it in mind. Okay, note a point. Arrow is equal to cos pi ax plus sin pi ay. That is equal to nothing but I writing this. This is the x y z. X y z. Okay, fine. We can draw the, this is the, we know that this point something, this is a rho. Okay, distance rho, we can connect the origin to point P. This point P, we can draw the perpendicular line. Okay, we know that in the conversion of the cylindrical to Cartesian, Cartesian to cylindrical, we can draw these diagrams x, y, z. Okay, this we know that this is the pi. Okay, this is the pi. In this direction, unit vector is the ay. Okay, in this direction, unit vector of az. Okay, this is the ax. Okay, this suppose this is the unit vector of arrow. Okay, this nothing but we can write the arrow is equal to cos pi ax plus sin pi ay. Integration of both sides cos pi and sin pi. Integrating cos pi and sin pi. We can give the answer. We can limits the pi. What is the limits of pi? Pi is nothing but 0 to 2 pi. Okay, we can put the limits. We can both sides we take the integration. That nothing but this arrow equal to 0. Arrow equal to 0 over 0 less than or equal to pi less than or equal to 2 pi gives 0. Already we discussed the last class also this topic. Okay, this is nothing but arrow is equal to cancel due to symmetry condition. Okay, every action, every element, every element 1 the opposite to element 2. This arrow, this is a minus arrow, that is it will be cancelled. Okay. Next, dH bar is equal to, we can say both side we take the integration. Both side we take the integration of dH. Direct, not directly writing, just dH bar is equal to, arrow will be cancelled. I by 4 pi rho square plus h square power of 3 by 2 power of 3 by 2 nothing but rho square d pi az only. Rho square d pi az. Okay, only one differentiation. This is a one differentiation. We take the one integration. This is a one differentiation d pi. We take the one integration. Nothing but both side we take the integration. Integration of dh is equal to integration of I by 4 pi rho square plus h square power of 3 by 2 rho square d by az. Okay. Nothing but integration of dh, nothing but this is the h. H is equal to h bar is equal to h vector is equal to, we take the one differentiation. What is the limits t pi? What is the pi limits? 0 to 2 pi. We know that 0 to 2 pi. Okay, writing 0 to 2 pi. Okay, in common I by 2 pi, I by 0 to 2 pi, 2 pi. Okay, I into rho square divided by 4 pi rho square plus h square power of 3 by 2 integration of 0 to 2 pi. This is a pi limits. This is a 2 pi, 0 to 2 pi. This is a d pi. 0 to 2 pi d pi. What is the integration of 0 to 2 pi d pi? I'm writing directly I rho square 4 pi rho square plus h square power of 3 by 2. This is the 2 pi. Okay, we can be cancel. This is a pi, this is a pi. 2 to the 4. 2 to the 4. We can write down the, this is the h is equal to, it's very important, just keep it in your mind. The asking the problems, I into rho square 2 into rho square plus h square power of 3 by 2. Okay, I'm writing unit vector of az, unit vector of az. Is writing unit vector of az. Okay, please observe the screen what I am writing. Okay, this is the final equation of the magnetic field intensity axis of circular loop. Very important. Okay, this is the magnetic field intensity H due to axis of circular loop. Don't confuse. In the first unit also we discussed the electric field intensity. Okay, this is circular loop. Okay, H due to axis circular loop. Okay, in this given, this is the problem. What is the problem? A circular loop located on x square plus y square equal to 9. Okay, z equal to 0 carries a direct current of 10 amperes. And given data, what is the given data? We know that in this given data, to find out magnetic field intensity and writing given data in the problem. What is the formula? Okay, this is the formula. Okay, this box is formula. In the question, first one at 0, 0, 4. First question 0, 0, 4. What is the in the given data? I equal to 10 amperes. And the height R Z, H is equal to 4. Don't confuse. H is equal to 4. In the above question, what is this? X square plus y square equal to 9. Okay. In this situation, I am writing the x square plus y square equal to 3 whole square. Okay, 3 whole square. Okay, nothing but this is the rho equal to 3. That writing, that is the distance. X square plus y square equal to rho square. X square plus y square equal to rho square. Nothing but rho equal to 3 whole square. Okay, this is the rho equal to 3. We know that axis of circular loop. Axis of circular loop. What is the formula? H is equal to I into rho square divided by 2 into rho square plus h square power of 3 by 2 unit vector of Az. Okay, this is the formula. In the given data, we know that all the equipment, we can find out the h at point of 0, 0, 4, not in h. Okay, this I is the 10 amperes. Okay, I is the 10 amperes. What is the rho? Rho equal to 3 whole square divided by 2. This is 3, 9, 3 square 9. H is nothing but 4. This is 16 whole power of 3 by 2. Okay, unit vector of Az. Unit vector of Az. Okay, this is the, we know that H is the nothing but what is the unit? Ampere per meter. Okay, this is H is equal to this simplification that they are writing, the simplification 0.36 unit vector of Az. Okay, this is the answer 0, 0, 4. Same answer. The B is also same answer. Nothing but at 0, 0, minus 4. What is the answer? 0, 0, minus. Nothing but same. I equal to 10 amperes. The given data I equal to 10 amperes. H is equal to minus 4. H is equal to minus 4. What is this? Rho equal to 3. You can get the answer. I think the same answer. The H square nothing but minus 4 whole square. That is 16 plus 16. Okay. That is the same answer. I equal to 10, 3 whole square divided by that formula. Just keep it in mind the formula. Okay. 9 plus minus 4, 16. Minus 4 whole square plus 16. Okay. Power of 3 by 2. This is the unit vector of Az. This is also same answer. 0.36 unit vector of Az. Okay. This will be ampere per meter. Okay. This answer will be same answer. This answer and this answer. Okay. I think is understanding magnetic field intensity due to axis of circular loop. Okay. If you not understanding, I repeat once again. Please, anyone responds? Anyone responds me? Anyone responds? If you all of you understanding or not? Any problem, then a response. Please unmute yourself and pick out. Please respond also chat box if you understanding or not. Please respond to chat box also. Oh no. Okay, Aishwarya, very good. Only response in the Aishwarya. Madhavan. Okay, very good. Attending the class 34 members. Only 2 members is responding. Anil, Srinivas. Anyone difficulty, please ask. Just in simplification, this is mathematical equation. Sign off. Okay, very good. I'm expecting the more people to listen and everything observe the screen. I think only 5 to 10 members response in the chat box. Okay, I think it's clear. The 6 to 10 members responding. Please, anyone difficulty, magnetic field intensity at axis of circular loop, please respond. Please, and the chat box also response. Simple. These are very important in the final equation. We can find out the problems also. Just keep it in mind the final equation. Just keep it in mind. All of you, I think, is understanding. Okay, this very important. This topic, this term, keep it in mind. We are using the next class. This term, keep it in mind. We are using the next class. Okay, this term. Okay, this is also this term. This is also next class. Very important. The box, just keep it in mind. Magnetic field intensity axis of circular law. Okay, we are according to problems. You can use the formula which is equal to I rho square to rho square plus h square power of 3 by 2 into vector of hz. Okay, fine. Okay, I'm stop sharing. I think today the section will be end.